Hello, my name is Chopo Gomez-Suevish. This is my introduction to a Monte Carlo simulation of a critical path. I have succeeded using Monte Carlo simulations as a team leader and as a coach. I'm sure this could help you. The problem is clear. We make plans and then slip. In other words, we arrive late. We make plans thinking we are going to get lucky. This is like a gambling addiction. We have the bad habit of making plans knowing that we will finish late. This is equivalent to pathological gambling. Let's say we want to put this red ball between the gray arrows. We think we're going to get these results. Watch the balls. In reality, chances are we're going to get results like these. If we keep shooting red balls, we might end up with something like this. Remember, we wanted the ball between the gray arrows. Do you recall the normal distribution? If you don't look it up, look up normal distribution or bell curve, or follow the link in the bottom of the page. To understand the rest, you need to have a fair idea of what a normal distribution is. If we throw enough balls and arrange them like this, we will get the bell curve. In other words, we should get a normal distribution, which is what we need for this explanation. This is a Gantt chart. If you don't recognize this, look up Gantt chart, or you can follow the link in the bottom of the page. In a Gantt chart, time goes from left to right. The green bars are tasks. The chain of connected green tasks is a plan. For now, we can call this sequence of green bars a critical path, but there is more to say about that. Let's just watch the balls. We shoot the ball into the future, and the task slips. So we paint the blue bar to show how late it is. Then we shoot again. This time, we finished in less time than planned. In other words, the second blue bar is shorter than the original green bar. However, we're still late. We click again. We are late again. Again, this one was late, so we're further late. And then we click one last time, again late, and we end up pretty late. In the end, we do this many times, and we end up with red balls on a normal distribution. Here's a story. If we assign probabilities to the duration of each task, in theory, we could aggregate the probabilities, but this is hard math. However, if we let the computer do the work for us, just like we shot red balls a moment ago, and let the computer shoot random numbers, and let the computer recalculate to push the schedule, we are doing a Monte Carlo simulation. It's that simple. We can read the results like this. The original green plan had a 12% chance of finishing on time. The blue plan has a 70% chance of finishing on time. With this bell curve, I can give you the probability of finishing at any particular date. That's it. The results of the Monte Carlo simulation is a diagram with the probability of finishing at any given date. Conclusion. This is as simple as possible just to get the gist. To work this out, we would need to say more about what is a critical path. We need to think about the probabilities of each task and simplify that to a working level. Then we need to learn to interpret the results. And finally, we would do this time and again, learning every time. That's it. Thank you.